Hello dear students, welcome to Dagurs Education Hub. So let's start our lecture today. In the last lecture we studied about the galvanometer and ammeter and voltmeter. How can we convert a galvanometer into an ammeter, or how can we convert a galvanometer into a voltmeter? We saw that galvanometer is a device which can measure the current and its direction, and we also saw that it can only measure a current up to a small amount, say microampere. Now what will happen if the amount of current is large? Now if we are using a galvanometer for a larger current, say 2 ampere or 3 ampere, then obviously that greater amount of current will damage our galvanometer and the instrument will be hampered. So to measure a large amount of current, what will we do? We will add a shunt resistance in parallel with the galvanometer, and we will get an ammeter. So ammeter becomes a device which is used to measure current and its direction and some larger amount of current. If we want to increase the measuring current, we can change the shunt resistance accordingly. So ammeter can measure current and galvanometer can also measure current, but up to a certain amount, say up to microampere. If larger amount of current flows, then the galvanometer will be hampered and it will be damaged. Now the maximum amount of current which can flow through galvanometer is known as full scale deflection current for full scale deflection, and it is denoted by Ig, So let's start a question on ammeter. Say this is a galvanometer and this is a shunt resistance. Now the resistance of galvanometer is 99 ohm. And a current I is entering. Now it is given in the question that that full scale deflection current can be only the full scale deflection current can be only 10% of the current I. So whatever the current is entering, the full scale deflection current, and what is the full scale deflection current? Full scale deflection current is the current passing through galvanometer. Now this full scale deflection current can only be 0.1% of this main current which is entering in the ammeter. So what is the question? The question is find the shunt resistance S. Okay, so this is the question. Now let's start our question. So this complete part is our ammeter, this galvanometer, and the shunt which is connected is our ammeter, and the maximum current which can flow through this, or the range of ammeter, is I. So current I is entering. So the current I is entering, and the full scale deflection current can only be 10% of the main current which is I, which is entering in the ammeter. So let's solve the question. See my dear students, this is our galvanometer, and shunt resistance is connected in parallel, and a shunt resistance is connected in parallel. We have to find this shunt resistance. A current I is entering. The current passing through the galvanometer, that is the maximum full scale deflection, can be only 10%. So, Ig is equal to 10% of I, which is equal to 0.1 I. So, the current which is entering through galvanometer is 0.1 I, and from Kirchhoff's current law we can say that the remaining current here will be I minus Ig, which is 0.9 I. Now, as you can see that G and S both are in parallel combination. The G and S both are in parallel combination, and we also know that in parallel combination potential difference across each resistance remains same. We also know that in parallel combination the potential difference across each voltage remains, across each resistor remains same. So, the potential difference across G will be same as potential difference across S. So, we can write that potential difference across G, potential difference across G will be equal to potential difference across S. Now, what is potential difference across G? Now, V is equal to IR, here I is Ig and the resistance is G. So, the potential difference here is Ig into G, and the potential difference across S is the current passing is I minus Ig into S. Now, what is Ig? Ig we have seen that this is 10%, so 0.1 into I. G was 99 ohm. I minus Ig is 0.9 of I, and we have to calculate this S. So, from 1 this 1 is cancelling. So, it is becoming 99 is equal to 9 into S. So, the shunt resistance is coming out to be 99 upon 9, which is equal to 11 ohm. So, the shunt resistance is 11 ohm. So, the shunt resistance is 11 ohm. Now, let us analyze the question once again. Let us analyze the question once again. You can do this question once again by your own. Okay, so you must try this question once again by your own, and then you can jump towards our conclusion or whatever analysis we are having of this question. So, we saw that the resistance of galvanometer is 99 ohm and the resistance of shunt is 11 ohm. The current passing through is I, the current passing through is 0.9 I, and Ig is 0.1 I. Now, Ig is the maximum current. Ig is nothing but the maximum current which can flow through the galvanometer without causing its damage. Say if the current is, if the current passing through the galvanometer is 0.2 ampere, then this galvanometer will be damaged and automatically the complete ammeter will be damaged. So, the full scale deflection current is the maximum current which can flow. So, the full scale deflection current is the maximum current which can flow through the galvanometer. The current flowing through the galvanometer can be less than that also. See what will happen if you decrease the shunt resistance. If you decrease the shunt resistance, the potential remains same. The potential remains same. So V is equal to IR. So I is inversely proportional to R. I is inversely proportional to R. Now, if you decrease the resistance, the current increases. If you decrease the resistance, the current increases. So, if I am decreasing this current, if I am decreasing this current, this resistor by further, the amount of current entering into this 11 ohm resistor or this shunt resistor will be more. So, the shunt resistance should always be less than the resistance of galvanometer. Practically, we should always take the shunt resistance less than the galvanometer. We should always take shunt resistance less than the galvanometer, because if the resistance of galvanometer is high, then less amount of current will flow through, because you see there is an inverse proportional relation. If the resistance is high, then the current will be less. Okay, so if the resistance of galvanometer is high, then the current passing through the galvanometer will be less, and there will be less chance of damaging of the galvanometer or our complete circuit. Say if the resistance was less than 99 ohm, then more amount of current would have flown from our galvanometer and it could have caused the damage. So, the shunt resistance should be smaller. Practically, the shunt resistance should be smaller. Now, see what is the resistance of the complete galvanometer. The resistance of the resistance of ammeter, see these two are in parallel, and we know the parallel combination, it is R1 R2 upon R1 plus R2. So, in parallel combination, this is becoming GS upon G plus S. Now, G is 99 ohm, S is 11 ohm, this is 99 plus 11. So, this is coming out to be 99 into 11 upon 99 plus 11. If we are doing, this is becoming 10, 9, 10, 11, this is becoming 110. Okay, this is becoming 110. So, from 11 we can cancel this 10, and the resistance of ammeter is coming out to be 9.9 ampere, 9.9 ohm. So, the resistance of galvanometer is even much lesser than the resistance of galvanometer and the resistance of shunt. So, the resistance of ammeter is smaller than the resistance of shunt and the resistance of galvanometer. So, if in the competitive examination, say if a NEET or JEE, if the resistance of ammeter is by chance it is coming greater than the shunt or galvanometer resistance, then it clearly means that you have done a calculation mistake. It clearly means that you have done a calculation mistake. So, a point to be noted here is that the resistance of ammeter is lesser than the resistance of galvanometer and the resistance of shunt. Okay. So, we can write it down here. Resistance of ammeter is smaller than that of galvanometer and shunt resistance. Because lesser the resistance, greater is the amount of current passing through the circuit. Now, if you take this circuit as total, this is ammeter, see the resistance of the complete circuit is 9.9, the resistance is 9.9, the current passing is I. If you increase little bit resistance, the resistance is 11 ohm, the current passing is 0.9. So, the current has decreased as we have increased the resistance. Now, increase the resistance further, Now as the resistance is 99 ohm, the current has decreased much further and the current entering is 0.1 ampere. So if you are increasing the resistance, the current is automatically decreasing. And for ammeter, our main objective is to find the current. So the resistance of the ammeter is much lesser than that of the galvanometer and that of the shunt resistance. Okay, dear students. So now let's move towards another question of ammeter. There is an ammeter and it is made by galvanometer. The resistance of galvanometer is G and the resistance of shunt is S. Such that only 0.2% current passes through the galvanometer. Only 0.2% of main current, and our main current is I. Only 0.2% of main current can pass through galvanometer. We have to find the resistance of ammeter. The resistance of galvanometer is given as G and the resistance of shunt is given as S. So what is happening in this question, that say a main current is entering into the ammeter, and of that main current only 0.2% is passing through the galvanometer. Only 0.2% is passing through the galvanometer and the rest is passing through the shunt resistance. We need to find the resistance of the ammeter. So let's do the question. So only 0.2% of the current is entering through the galvanometer. What does this mean? This means that the current for the full scale deflection, that is Ig, is 0.2 of the main current. Now it is better if we take the main current as 100 ampere so that our calculation can be much easier. Say the current entering through this is 100 ampere. We can take this as 100 ampere. Now 0.2%. Now 0.2% of 100. Now 0.2% of 100. So this is coming out to be 0.2 ampere. So from here 0.2 ampere is entering, and in shunt resistance the current enter will be I minus Ig. So 100 minus, we will do 0.2. So 100.0 minus 0.2. So this is coming out to be 99.8 ampere. So this is coming out to be 99.8 ampere. And this is our full scale deflection current. Now what we do? Do not remember the formula blindly. What we will do? We will use the concept as we have used in the previous problem. As they are in parallel combination, so the potential difference across the galvanometer will be equal to potential difference across the shunt. So let's move forward. potential difference across galvanometer is equal to potential difference across shunt resistance. So, what is potential difference across the galvanometer? The potential difference across galvanometer is Ig into G, and the potential difference across ammeter is I minus Ig into S. So, what is Ig? Ig is 0.2 and G is G. I minus Ig we have got as 99.8 into S. So, S is coming out to be G. It is coming out to 0.2 G upon 99.8, and I think it will be 499. Let's check it. If we divide it by 2, 2 4s are 8, 499, 2 9s are 18. So, this is coming out to be 499 G upon 499. Now, this is not the resistance of ammeter. This is the resistance of shunt. This is the resistance of shunt. What is this? This is the resistance of shunt. So, again we have seen this clearly, that the resistance of shunt, is less than the resistance of galvanometer. Now, when we will find the resistance of ammeter, we will again see that the resistance of ammeter will be less than that of the shunt and less than that of the galvanometer. Let us check it. So, if we want to find the resistance of our ammeter, as they are in parallel combination, so the resistance of ammeter will be Gs upon G plus S. Now, S is G by 499 and this is G plus G by 499. So, this is coming out to be 500 upon 499. So, this is G square upon 499 into 499 upon 500 G. So, from G, a G is cancelling, 499 is cancelling. So, the resistance of ammeter is G by 500, which is again less than that of the shunt and ammeter. So, the resistance of galvanometer was G, the resistance of shunt was lesser, G by 499, and the resistance of ammeter is again less, which is G by 500. Okay. Now, there are two important points. Always remember that the resistance is connected in series in the circuit. Sorry, the ammeter is connected in series in the circuit. And the second point is, in ideal condition, the resistance of ammeter is considered to be 0. In real conditions, there is some resistance of ammeter. As a result, the current measured is less than the actual current. Is less than the actual current. So, these are the 3 points which you must learn, and you must remember these points now only. So, now let us do a question on voltmeter. Let us do a question on voltmeter. Easy question, not that difficult question. Say that we draw we create a galvanometer using a voltmeter, and the range of voltmeter is 0 to 5 volt. We create a voltmeter using a galvanometer, and the range of galvanometer is 0 to 5 volt. The resistance of galvanometer is 50 ohm, and the current passing through it is 50 microampere. Find the value of resistance S connected. So, what happened that in galvanometer, you can check the question and try it by your own once. What happens when we make a voltmeter by using a galvanometer? We connect a resistance in series with the galvanometer. So, if this is a galvanometer, what we are doing? We are connecting a resistance in series with this galvanometer. Now, the resistance of this galvanometer is 50 ohm, and the current passing through it is Ig is 50 microampere. We need to find this resistance S, and one more thing is given, that the range of the galvanometer is this galvanometer is 0 to 5 volt. Now, you know that V is equal to IR. So, V is equal to I. Now, the resistance of this voltmeter, now as G and S are in series, so the resistance will be G plus S. So, we will be using this formula to solve our question. So, V is equal to I into R plus G. Now, the maximum voltage which it can measure is 5 volts, as the range was 0 to 5. The current is 50 microampere, and R plus G, sorry, this will be G plus S, because G and S were in series. So, this will be G plus S. Now, G is 50 and S we need to calculate this. So, this is becoming 5 upon 50 into 10 to the power minus 6 is equal to 50 plus S. So, 50 plus S is coming out to be 10 to the power 5. So, S is coming out to be, now if you add 1 lakh plus 50, it will approximately equal, you can give this answer in this way also, 10000 50, and you can approximately write this as also, we can approximately write this as this also, or you can approximately write this as 100 kilo ohm. We can write this as 100 kilo ohm. So the shunt resistor, or you can just write this in this way only, approximately. Now, how this 10 to the power 5 is becoming? This 10 to the power 5 is big because you see 10 to the power 6 is coming at the numerator, and this is 5 by 50 is 1 upon 10, and from 10 1 power of 6 is cancelling, that is why it is becoming 10 to the power 5. So, you can approximately write this as 10 to the power 5 ohm. So, what we are seeing actually here, we are seeing that the value of shunt resistance is much higher than the value of the galvanometer. So, value of the shunt, the shunt, not shunt, value of the resistance S is much higher than that the value of the galvanometer, which is G. And in ammeter we saw that the value of the shunt S is lesser than G, and in galvanometer the value of S is larger than that of the G. So, there are few points, let us write. Now, first point is that the galvanometer is connected in parallel. The galvanometer is connected in parallel in the circuit. Now, the second point is in ideal condition, the resistance of galvanometer is infinite. In real condition, this will be the resistance of voltmeter. And here will also be voltmeter. So, the voltmeter is connected in parallel. So, the voltmeter is connected in parallel in the circuit. In ideal condition, the resistance of voltmeter is infinite. In real condition, the resistance of voltmeter is high. Now, why the resistance of voltmeter is high? See the resistance, now just see the previous question, that the resistance of S is 10 to the power 5 ohm. Now, this 10 to the power 5 ohm makes the resistance of voltmeter very high. As the resistance of voltmeter is high, the amount of current entering will be less. As the resistance is high, the amount of entering current will be less, and as a result, the galvanometer will not be damaged. And we know that we are measuring potential. So, potential difference V equals to IR. If we want to keep our resistance small, to increase the range, we can increase the resistance. V equals to IR. There is a limitation in I. The maximum current that can flow is 50 microampere. So, this is becoming a constant for us. We cannot increase, we can decrease, but we cannot increase. So, the maximum current is becoming 50 microampere. That means there is a constraint in the relation. So, we can take out I. So, V is directly proportional to R, V equals to IR. Now, I has a limitation, I has a constraint. So, V is directly proportional to R. If we increase our resistance, there will be increase in the voltmeter or the voltage. So, to increase greater voltage, we can increase the resistance. Okay, dear students, so voltmeter is connected in parallel. In ideal condition, the resistance of voltmeter is infinite. Why infinite? Because we can measure maximum amount of voltage, but in ideal condition, the resistance of voltmeter is quite high. So these were the few questions regarding voltmeter and ammeter, and the theory part we have already studied in the last class. So this was today's lecture. Let's meet in the next class. So thank you so much.